Explain the three assumptions needed to perform an ANOVA. This information you have it from your blackboard. The document where you can find these answers is chapter 2, part 4. If you go to chapter 2, part 4, you'll find this information. If I'm not sure between part 4 and part 3, but this information is there. Where we're talking about normality, independent of errors, and constant variance. Those are the three assumptions that you need to know. Normality, normality, independent of errors, and to check if the variance is constant. So what happened with this question? Some students were able to list them, but they failed to explain them. So by listing them, you're getting 3 marks for listing, and again a mark for each assumption for explaining how will you assess that assumption. The information is there on that document. For example, let me give you a simple example with the constant variance. Some students were saying for the constant variance, I will check if the variance is constant. But you're not explaining by doing that. How do you check it? That different methods that you can be used to check for constant variance. We have been testing for using the Hartley's test. Why were you testing using the Hartley's test? Because you wanted to check if the variance is constant. We've been testing using the Bartlett's test. Why that? It was to check if the variance is constant. Again, you can use the even from that document, the Levin test. Those tests they are what to check if the variance is constant. Or you can simply to answer this question in a correct way. For example, the constant variance, you will say, I will check if the variance is constant. How will you check it? I can use the Hartley's test to check if the variance is constant. If I fail to reject the null hypothesis, it means the variance is what? Is constant, and you get the other mark. Or you do the same with the Hartley's test. Or if you want to go the root of, use the root of the plot, residual plot, you can say I can uh, draw a residual plot between errors and the response variable. If there is no pattern between the errors, it means the variance is constant. So that there were different ways where you can explain how will you assess this variance, to assess if the variance is constant or not. Going back to normality, same thing. How can you check for normality? We've been talking about these things even in the first semester, that you can simply draw the scatter plot of, sorry, the histogram of the errors. But you cannot say I will draw the histogram of errors on what? You must explain what you are expecting from that plot. If the histogram of errors is giving you a what? A symmetric shape, the histogram is not skewed, it means the normality assumption is not what? It's not violated. You are busy explaining how can you check these things. So, but the information is there from that, I think chapter 2, part 4. You can go and check it. I think you'll find all this information. B, I gave you that statement, and I ask you to indicate the response variable. The response variable, guys, is the outcome. Is the outcome of your what? Of your experiment. Your outcome of your experiment is what? Is the satisfaction. Here it is. The response variable is the, because here is the internet service provider conducted the study to see if reducing the number, I'm reading this part, guys. So the answer is here. Why did the person decide to do this study? So your output is what? Your output is to check the what? The satisfaction of the users, isn't it? If they reduce the number of pop-up ads, will it improve the satisfaction of the what? Of the customers? So satisfaction was what? Was your response variable, because it's the outcome. And then oh, you can see this. Okay, it's fine. Now, so the response variable is the satisfaction. So just write satisfaction, you're fine. What are the treatments in this study? What are the treatments in this study? Are the pop-up ads, isn't it? Adverts, isn't it? And how many are they? They are 2. They are 2. So the treatment. So the students who didn't see that there are 2 questions here. Before the student will only answer this question. They will list the number of treatments, but then don't indicate how many treatments we have. So there were only 2 treatments, and then the last one, Roman figure 3. Guys, this one, it was a giveaway. Roman figure 3. What are the experimental unit in the study? The experimental unit was what? Yes, the experimental unit. The users, isn't it? People are using that, visiting those websites. And how many are they? There are 1,000. So experimental unit, the subscribers, how many are they? There are 1,000. So you get your 2 marks. C, if you have a question, please raise your hand and then I will stop. C, briefly explain how will you use multiple range test for unbalanced CRD. The only thing that I wanted you to emphasize is how will you deal with what? How will you deal with step number 2? That was my main focus. Because I'm saying, how will you apply Duncan multiple range test for unbalanced CRD? You say you arrange the means, that one is fine. You find the standard error. If you check your scripts, some of you who just said, I will just find the standard error. How will you find it? Because the problem is unbalanced. That's where I wanted you to bring in the issue of what? The issue of the harmonic mean. The issue of the harmonic mean. So I wanted you to explain that, oh, since the problem is not balanced, I will first find the harmonic mean, because the replications are not the same. The other steps, it was not challenging for you. I only took marks for, in most cases, for the students who failed to indicate that there's a part where they have to find the harmonic mean. But the majority of the students got this one right, because the information is there from the notes. D, you are given 4 treatments. Yes, 4 treatments. An SSE of 2000. SSE of 2000. And you are asked to, and your N is 20. So you'll need this information, guys. 20 SSE is 2000. And then it means, since you are having 4 means, it means your R is what? Your R is 5. 5 from each treatment. The problem is balanced. So R is 5, N is 20, and the given information there is what? Is the means. The problem was here now. Guys, the reason why I gave it 2 marks, I assume that everyone knows this thing from this part. I asked you to write the model. You write the model, guys. Yij is equal to the population mean plus tau I plus Eij, the errors. But I said write the model. So I was giving a mark for you for writing the model and another mark for explaining each parameter. So you are supposed to indicate what does Yij represent. Yij represent the response variable. Mu is the population mean. Population mean. Tau I is the effect of the ith treatment. And then because you have to define the parameters based on what? On the given problem. You have to indicate what is your treatment from this given problem. So is the effect of the ith fabric dye what, isn't it? You must check what is your treatment from the given statement. But even if you wrote treatment, you didn't indicate what is a treatment based on the given problem. I was giving you a mark. I was giving you the mark that you deserve. I was giving you the full mark. So most of you failed to explain the parameters. So guys, you must know these models. So if you fail this one, imagine if I gave you that one of uncover. What was going to happen? But that one is even long. So you must know each and every model. Because come test 2, it will be a different story. You must know these models. So this information again is there in your study guide. You can just check the model of the CRD model. So it's there in your study guide, guys. Let's make sure that we push the part where we need more time. Perform pairwise comparison using the Tiki method. Using the Tiki method. So what was happening here is that the problem is balanced. Remember, we're having 5 replications per treatment. So the problem is balanced. That is the first part. We know that the problem is balanced. So what is left now? What is the standard error for Tiki when the problem is balanced? The standard error for Tiki when the problem is balanced is the same standard error that you used for Duncan multiple range test, student Newman-Kells test, which is what, guys? Because the only part that was difficult there for majority of the students is the standard error. So the standard error was the square root of MSE over T, over R, sorry. So this was the case. Let me share this. I'm coming. I'll come back to this one. So I don't expect me to give you the memorandum. I'm not going to give you any memorandum. This is my way of giving you the memorandum. Can you see these guys? Leaders?
Yeah, we can see.
How many treatments do we have from the problem? We're having 4, right? So to check the value from studentized Newman-Kells range, we use T and degrees of freedom of errors. You see, Q of T, that's why we're having 4 there. Because it's T, not T minus 1, it's T. Some of you were saying t minus 1. Where did you get that? Because it's if the information is even there from your notes. It's t degrees of freedom of errors, not t minus 1. So this is what we are supposed to do, guys. All the means were what? All the means were not the same. Were the same, sorry. So the take value was what? 20.25 or 20.0 something. But you can use your mathematics there. But it's 20 point something, if I recall very well. So all the means were not were less than what? All the means were less than the take value, which means all the means are what? The same. There is no difference between the means. But there's a question that you guys you failed to answer. I said indicate which means are the same by joining the lines. There were different ways of doing that. There were different ways of doing that. You can just do a line like this, or just do something like this. Let me show you. Join the lines, guys. Join the lines. This means you're simply saying that this means are what? These means are the same. You just simply join the lines here. You're simply saying that all the means are what? Are the same. So suppose that in a case where, so I want to emphasize this one because not always the case that all the means will be the same. In a case where mean 1, let me go up. Mean 1 and mean 2 are not the same. So it means you're going to do what? Suppose this one is greater than, for our test, they were the same. In a case where they're not the same, maybe I want to I change this to greater than. Suppose this was the case, and maybe even this one was greater than. Suppose mean 1 and mean 2, they were greater than the T alpha, and mean 1 and mean 3, they're greater than T alpha. So when you are asked to join the lines for the means which are not the same, you will do something like this. If they're not the same, suppose these two are more than what? 20.25. So when you join the lines, you do something like this, guys. Now we focus on mean 1 and mean 4. Mean 1. So now if you join the lines, mean 1 and mean 4, you say they're the same, right? There is the line to represent mean 1 and mean 4 because we're saying it's less than. Mean 2 and 3, you go to mean 2 and mean 2 and what? Or mean 2 and mean 3. Yes, you are simply saying this one is not that the same. Mean 2 and mean 4, again, you need another line which will represent mean 2 and mean 4. And the last one, mean 3 and mean 4. Now you'll do something like this. If you're asked to indicate, you see, this one now is, you are saying, you see, it means here 1 and 3, there is no line joining 1 and 3, isn't it? There's no line joining 1 and 3. So it means you are simply saying 1 and 3, the means are not the same. There's no line joining 1 and 2. It means again 1 and 2, the means differ. Do you get it, guys? Do you understand what I'm trying to explain here? We're left with 10 minutes. Okay. But for our test, all the means were what? All the means were the same. So we failed to reject. So the next question which followed was, based on your findings from Roman figure 2, what do you think was the conclusion when using the ANOVA table? It means we failed to reject the null hypothesis and conclude that the means are the same. That's what happened when testing for the overall model. It means the means are what? Not the same. Well, they are the same, sorry. Because all the what? There's no mean which is all the means here that they are the same based on our findings from Roman figure 2. So let's go to the last one now, which is question 2. Let's move to question 2, guys. So question 2. Hey, this one, some of the students made a big mistake. It says the study was conducted to compare 4 treatments, which means the degrees of freedom of the treatment is 3, based on 6 replications per treatment. So it means 4 by 3, 6 is what? It's 24. 24 minus 1 is 23. It means this one will be 20. Based on I'm getting this information from this statement. But now it says complete the following ANOVA table. Assume that the treatment's sum of squares SST accounts for 60% of what? Of the 10,000. We have some students who wrote one, they said to change my 10,000 to 1,000. And it's going to affect almost the remaining part. So the 60% of 10,000 is what? 6,000. 60% of the 10,000 is 6,000. This one will be what? Will be 4,000. Now use your mathematics there. What will be our thing there? It will be 2,000, right? And this one, it will be what, guys? Is it 200? What is 4,000 divided by 20? Help me, guys. We are left with only 9 minutes.
It's 200.
100.
200 divide 2,000 by 200. Your F.
10.
And this one, if I recall very well, it was 3.10. So this is what we're supposed to do, guys, when you're asked to complete. So the mark that was allocated, it was for this value, this one, and these 2. That is why it was 4 marks. So marks that were only allocated for the red part. So the 4 marks there, it was only for giving me that information, only the one which is in red color. So here I said assume the model 2 is appropriate test for the relevant hypothesis. That's why I saw it's a miracle here. I was given a lot of models, hypotheses, different hypotheses. I don't know where did you get those hypotheses, but it was somehow. So please, this one is your task. Go to your study guide, check what is your model 2, the hypothesis of model 2. So this one is yours, guys. For the sake of time, this one is yours. Go ahead and check it. Roman figure 2. Roman figure 2, I asked you to give me the 90% confidence intervals for various components and the ratio. This question was also there during the tutorials, right? So this question, you are not seeing this question for the first time. It was there during the tutorials. So allow me to go to the whiteboard so that I used only 2 minutes to do this. So what was expected from you is this is the case. What was expected from you guys, the variance component I showed you in class, I said you can find SSE over A, which is chi-square of 0.05, because we are given 5%, 0.05, and the degrees of freedom of error, it was 20 there. And the upper part is SSE divided by the chi-square of 0.95 and 20. And you remember your SSE is what? Your SSE is 4,000. So imagine for a person who made a mistake and wrote a wrong value there. So the degrees of freedom of from the chi-square now, let me look it for you, because if I have to ask you guys, it will take more time. So the degrees of freedom of error there is 20. You look for the value from the chi-square table, which you look for 20 and 0.05 is 31.41. So the tabulated value is 31.41. The upper part also divided by the upper part will be I think it's 10.85. Can someone confirm the values for me, please? I'm looking at the time, guys. Time is no longer on our side. Are the values correct?
It's correct.
Thank you. So this is what we are expected to find, guys, and then it was allocated 3 marks to do this. 3 marks to just to do the substitutions. If you can check, you don't have a lot of work to do there. Just substitute and get the answer. The other one is SST, guys. SST divided by RC. SST divided by RD. You know what you put in the middle, right? Is the variance of the other one now is tau now. This one is tau. We remove this. SST, we agreed that is 6,000. Some they were writing 10,000. Replications we agreed is 6. Chi-square of 0.05, and the degrees of freedom of treatment for a given problem was 3, and 6,000 divided by chi-square of 0.95 and 3 multiplied by 6. So some students they were forgetting to what? To multiply by this 6. So the tabulated values here for the left side, 3 and 0.05. It was for the left side, it was 3 and 0.05, 7.81, and the upper side it was 0.35. So you do your mathematics, guys, there, and then you'll find the answer. The last one now is the confidence interval of the ratio. This one is if students fail to do the calculations. Everything was, most of you managed to do the substitutions right, but when coming to the final answer, you failed to punch your calculator. So that one you need to just go and practice, guys. So the last one here now is the uncover part. The uncover part, leaders, this one, I don't know why you got it wrong, because there was a day where you said these things of summarizing information for us, you are confusing us. So please, when you ask us a question, don't summarize the data for us. And I decided not to summarize the data for you guys, but you fail to get the answers. So for the uncover, I will give you the memorandum for this part, and please go and try to get these values. Let me share the page. Go and try to get these values, guys, so you can copy the values down, or since the the um, the class is recorded, you can pause when you get here, isn't it? This was the what? This is what was expected from you guys. Or the mark is not allocated there. This one, it will mislead people, students. They will say, I want my mark. So marks were allocated like that. It was allocated 10 marks. 10 marks to give me this part, to give me that part, and 2 marks to conclude. Understand the logic behind? 10 marks for the uncover, and then 2 marks for the testing part. So to make life easy for you, you see what I did here, testing for the adjusted treatments, and you write what is the decision, what is the conclusion and the decision. Testing for the regression slope, and then you indicate what is your decision and what is your conclusion, and you are done. You see, as long as I've indicated what I'm testing for, it's fine. Testing for the adjusted means, it's clear what I'm testing here. Testing for the regression slope, it's clear what I'm testing there, and then you conclude. The last, with the remaining 3 minutes, the last question now, it was what? The adjusted treatment means. Adjusted treatment means, this page is not going to. The adjusted treatment means the first one there, I think it was, sorry. This one here, answer was 75. Second one, answer was 88 point something. And the last one is 83 point something. So the B star, I think it was negative 0.071. Can someone help me with the B star value here? B star value, what was the value, the value? Anyone who can help me, please? But it's fine, even if it's fine, you can.
Negative 0.071.
Yes, negative 0, thank you very much. So you do your calculations there, as long as you have the negative 0.071. Apply your maths there, and then you'll find figures, some of the figures that I'm trying to indicate here. So there was a mark for substituting y bar 1, and the mark for the final answer. The mark, if a student failed to get the B1, B head star, but you managed to substitute this 76.2, there was a mark that a student who managed to substitute, get this 8, managed to substitute this 80.6, there was a mark for that, and 83.2, there was a mark for that. So even if you fail to find the correct answer here, But if we manage to do the right substitutions for this one, there was a mark for that. I thank you. Enjoy. So I'm done giving the feedback. So moving forward, please guys, try to balance your work. Time is no longer on our side. Test 2 is coming in 3 weeks. You'll be writing a test 2. So it will be better if you collect your script. For those who didn't collect their scripts, please collect your script in case you did what, so that you can see your mistakes. Because now I have more than 150 scripts in my office. So it means half of the class, they don't know how they've performed, and I cannot give you the marks on blackboard until you come and collect your script yourself.
So
So if you
say,
decide not to collect the script, you'll never know your marks.
say,
Yes,
yeah. When can we come and collect?
I'll be in the office on Monday.
All right.
Yeah. If you decide not to collect, so it means you only know your marks during the what? During the module mark. Mapanga. And the danger of that is if there's a mistake, we cannot fix it if the marks are already submitted to the HOD. So the window for correcting the marks is still open. So if you fail to collect your script and then you try to come after 3 weeks, if there's a mistake, we cannot correct it because the marks will be submitted to the what? To my HOD's office. And then you won't win the case because the rule is that when you are asked to come and collect the script, you must do so. Mapanga, Ribuan, I cannot hear my sister. I don't know what's happening. Any question? Yes, Ribuan. Ribuan, can you simply please write on the white on the charts there. Just summarize the message, please. Any other question? While Ribuan is still writing the message there. I know you're supposed to attend sampling. We're left with uh, 9 minutes. But for the class issues, I think we're scope for test 2. We cannot now we cannot tell my sister because we still have 3 weeks for teaching, right? So we will be guided by what will be covered by that time. We'll be guided by what will be covered by what that time. We still have 3 weeks, my sister. Oh, okay. The final value is for the ratio is 0.27. The lower limit and the upper limit is 0.937. The lower limit, Candy, is 0.27, and the upper one um, is what? Is 0.937. The tabulated value when calculating the lower side is 3.10. The tabulated value when you're testing for the lower side. When testing for the upper side, the tabulated value is 8.66. I hope that will also help. No. That is why I'm saying, Mapanga, it will depend with what will be covered because you cannot write a test based on one chapter. Assuming that is the only chapter covered by the time we get to the 16th. So it means first part, some of the first part will be included. But I don't think so. You don't have to worry. Will I think by the 16th, by the time we get to the 16th, will be having enough scope for test 2. So test 2, there's a possibility that it can cover 3 chapters. I think Mr. Boy can finish chapter 4 next week. Doesn't it? A week is enough to finish that chapter, and then you go to chapter 5. So I think chapter 3, 4, and part of 5 will be part of the test 2. But now I'm not sure of what I'm saying for now. Yes, guys. Any other question? Clarity? Can I get the last question, please? Or let me stop the recording.